In the medieval era, Islamic astronomy was the most advanced of its time. The Islamic people inherited the study of astronomy from ancient Greece and continued to make observations of the stars. The oldest drawings of constellations date back 1,000 years. They would greatly influence subsequent study of astronomy. In the 15th century, Islamic astronomers built the largest observatory of the time. By making precise observations of the sun, they were able to accurately determine the length of a year.
And this calculation is less than 30 seconds different to modern calculations. And this is a remarkable result considering that they only had mechanical devices.
Furthermore, according to recent research, it has been found that heliocentrism, proposed by Copernicus, was conceived based on the accomplishments of Islamic astronomy.
While traditionally Copernicus has been seen as an isolated genius, we found that he relied heavily on Islamic astronomy.
Islamic astronomy has played an important role in furthering astronomical study. This program will explore that unknown glory. Innumerable stars glitter in the night sky. Many of them have been given names. Various constellations were also created, based on animals and legends. How were the shapes and names of these constellations decided on? One origin can be traced back to the Middle East of more than 1,000 years ago. Our journey takes us to a desert in the United Arab Emirates. This is Hassan Hadidi, the CEO of a local group that conducts astronomical observations. A descendant of the Bedouin, or desert people, Hadidi claims that a close relationship with the stars has been passed down through his family lineage.
ارتبط اسم العائلة، عائلتنا عائلة الحريري، بتجارة الحرير. تجارة الحرير كانت من التجارات الرائجة في القديم، وهذا الأمر كان يتطلب أيضا أن الناس اللي بيعبرون الصحراء ويترحلون فيه والقوافل هاي تمشي، هاي لازم تعرف اتجاهاتها وتعرف مقصدها، وهاي ما تبين إلا من خلال النجوم. فمعرفتنا بالنجوم ومعرفتنا بالدلائل النجوم كانت شغلة هامة جدا.
The people of the Arabian Peninsula led nomadic lives, or made a living carrying goods in the vast desert. In the featureless desert, the stars of the night sky were absolutely vital to determining direction and one's location.
الأوليين كانوا يعرفون النجوم ويتعرفون عليه أن النجوم اللامعة كانت في السماء باينة واضحة جدا. هالوضوح هذا أدى أن الأوليين يتعرفون على أشكالها، يكونون منها أشكال فيوصلون مثل ما يسمون صغارية توصيل الخطوط. هالنقاط هذه يوصلون فيها فيتعرفون على أشكال نجمية.
The sun begins to set. The stars become visible above the desert. Hadidi reveals something even more surprising.
فمثلا على سبيل المثال لو أخذنا خارطة السماء وأسماء النجوم فيها وقضية رسم الرسومات والأشكال النجمية، العرب أسهموا في أسهامات جدا جليلة. سماء الصيف هذه تتميز بشيء يسمونه مثلث السماء الصيفي اللي هو 3 نجوم، نجم فيغا ونجم ذنب ونجم اللي نسميه نحن الطير.
Hariri points out Vega in the constellation Lyra, Deneb in the constellation Cygnus, and Altair in the constellation Aquila. These 3 stars form the summer triangle, which is visible throughout the northern hemisphere.
تصوروا وياي يا جماعة أن معظم الأسماء الموجودة هذه أسماء عربية، والطير من العربية ماخذين الطير، والذنب ماخذينه من الذنب، ذنب الأوزة، فهذا في كوكبة الأوزة في الذنب.
Finally, the star Vega in the Lyra constellation derives its name from the Arabic word meaning to fall. Many of the brightest stars have names originating from Arabic, such as Rigel in the Orion constellation and Aldebaran in the Taurus constellation.
المطلع على علم الفلك سيرى بوضوح أن إسهامات المسلمين والعرب فيها كبيرة. من منطقتنا من بلادنا خرجت العلوم هذه التطبيقية وانتشرت عبر العالم وأصبح لها أسس جميلة جدا، فهذا من دواعي فخرنا ومن دواعي اعتزازنا.
Astronomy was originally well developed in ancient Mesopotamia, Egypt, and Greece. In the 7th century, it was taken up by the Islamic dynasty and came into full bloom. Until the beginning of the European Renaissance in the 15th century, the study of astronomy was centered in the Islamic world. A valuable document demonstrates that astronomy was indeed developed in the medieval Islamic world. It is a history book put together in 16th century Turkey. Astronomical observations of the time are depicted in this book. This is a large observational device known as a celestial sphere. At the time, numerous devices were used to make observations more detailed than any that had been conducted before. But why did astronomy develop so much in the Islamic world? One major reason lies in prayer, which must be conducted 5 times a day. An important aspect of the prayer is the direction one faces. One must always pray in the direction of the holy city, Mecca. In addition, the 5 daily prayers begin before sunrise and are timed to the position of the sun in the sky. Astronomy was thus vitally important to determine which way to face and what time to pray, no matter where one was located.
Dinin verdiği bu yükümlülükler İslam dünyasında astronominin ileri düzeye gelmesine sebep olmuştur diyebiliriz. Sonuç olarak söylemem gerekirse, İslam dünyasında Orta Çağ'da astronominin gelişiminde İslam dininin önemli bir etkisi vardır.
Astronomy was incorporated into the Islamic world due to its religious necessity. Even now, a strong link remains between astronomy and the lives of Islamic people. It is late May, and the month of fasting known as Ramadan is about to begin in the United Arab Emirates. Occurring once a year, Ramadan is an important religious duty in which one spends a month fasting during the day. Throughout Ramadan, restaurants are generally closed until sundown. It is said that the purpose of fasting is to purify one's body, throw away desire, and heighten one's religious piety. The beginning and end of this fasting is actually signaled by the moon. In Islamic teachings, it is stated that one should look at the moon to decide the beginning and end of fasting. The Islamic calendar is based on the waxing and waning of the moon. Normally, the first sliver of moon after a new moon is the first day of a new month. Adherents of Islam are required to check when this new moon crescent appears. Thus, in various Islamic countries, confirming the shape of the moon and deciding the beginning of Ramadan are customs carried on even today.
شهر رمضان أنزل الله سبحانه وتعالى فيه القرآن، وهو الكتاب المقدس لدى المسلمين، القرآن الكريم أو القرآن العظيم. مهم جدا بالنسبة للمسلمين في جميع أنحاء العالم حينما يريدون صوم رمضان رؤية الهلال.
The evening of the first day of fasting. At the signal of sunset, mosques begin serving a meal. People slowly consume their first food and water in half a day. When they finish eating, they head inside to pray. The moon peeks around the side of the mosque. The people of Islam live and breathe to the rhythm of the moon. This was the driving force behind their development of astronomy. The medieval Islamic world pursued astronomy based on its religious teachings. A rare document said to be the culmination of medieval Islamic astronomy is preserved at the University of Oxford, United Kingdom. Called the Book of Fixed Stars, it contains the world's oldest drawings of constellations. It was put together by the astronomer Al-Sufi in the 10th century, roughly 1,000 years ago. This is the constellation Gemini. The twins here have an Arabian air to them. Compared to Western images, they are depicted in a more dynamic pose. This is the constellation Perseus. The monster of Greek myth, Medusa, is depicted in a vivid manner. On the left is a star catalog, listing data on the stars that make up the constellation. The stars are documented in detail, including their brightness and color, location when seen from the Earth, and placement in the constellation.
What Sufi did was, first of all, to take Ptolemy's values, bring them up to date, because the stars changed places very gradually over the centuries, indicate their native Arabic names, sometimes criticizing and correcting Ptolemy.
Particularly unique to the Book of Fixed Stars is the Andromeda constellation. Unlike the Western depiction, Queen Andromeda is depicted in the Book of Fixed Stars with fish over her stomach.
But what is most interesting about this figure is that not only do you have Andromeda, but you have superimposed, in fact, two fish. And some people say that this fish is a pre-Islamic constellation before the Greek constellations were adopted.
Hidden in these curious fish shapes is an important record of astronomical history. At the mouth of one fish is a fine cluster of dots, resembling a stain. In the description, it says, "A cloud-like form is visible." What is located at this cloud-like form is actually the Andromeda Galaxy. Approximately 2.5 million light-years from Earth, it is a galaxy consisting of 1 trillion stars.
And this is, we think, the first depiction of the Andromeda Galaxy.
The cluster drawn at the mouth of this fish is in fact the oldest depiction of the galaxy by mankind.
The Andromeda Galaxy, which is an enormous galaxy, and which is obviously visible to the native eye.
The depiction of constellations as seen in the Book of Fixed Stars was subsequently taken up by later astronomers. The constellations that we know today are derived from the creations of Islamic astronomers. This is Istanbul, the capital of the Ottoman Empire that once conquered the Islamic world. This museum has gathered scientific tools once used by astronomers of the region. Astonishing astronomical observation tools invented through Islamic research are displayed here. We are guided by Attila Bir, a specialist in the scientific tools of medieval Islam.
İslam Orta Çağ'ında çeşitli bilim aletleri geliştirilmiştir. Bunlar arasında en ilginç olanları şunlardır. Bunlar İslam Orta Çağ astronomisinin en önemli aleti usturlaplardır.
The astrolabe is an astronomical measuring device originally invented in ancient Greece. It spread to the Islamic world and was put into practical use in the 8th century.
Usturlaplarla yıldızların konumu ölçülebilir, güneşin konumu ölçülebilir, zaman ölçümleri yapılabilir ve her türlü mesafe ölçümleri yapılabilir. Özetlemek gerekirse bu bir analog bilgisayardır.
This is a depiction of sailing in medieval Islamic times. A seaman is holding an astrolabe in his hand. It was a vital instrument for sailing. It is said that merchants of medieval Islam were able to trade across the Indian Ocean thanks to the achievements of the astrolabe. But how was the astrolabe actually used? The pointers on the front ring mark the locations of bright, easily seen stars. They are an accurate reproduction of the locations of the stars as seen from the Earth. The ring in the center is engraved with a yearly calendar, while the outer ring displays the time of day. Does this resemble something familiar? That's right, a planisphere. When you line the date and time up on the planisphere, you can see where the constellations will be. Using the astrolabe, one can determine the time and one's own location based on the position and height of the stars. This is how you would determine the time. First, you set the positions of the stars to midnight of that day. Then,
Usturlabın içindeki yıldızlardan bir tanesini gökyüzünde belirleriz. Aleti yukarı kaldırarak cetvelle yüksekliğini ölçeriz. Yükseklik dairesinin üzerine getiririz.
this lets you know how much the stars have moved since midnight, allowing you to determine what time it is. By using the astrolabe, astronomical observation, land surveying, and sailing flourished in the medieval Islamic world. Discoveries made using the astrolabe would lead to even further development of the study of astronomy. This is the Museum of the History of Science at the University of Oxford. Many extraordinary astrolabes are preserved here. This was created around 1220 in Persia, now known as Iran. It was made with gears inside. According to Zoke Ackerman, a professor at the museum, this astrolabe is highly unique.
The astrolabe we're looking at here is the earliest geared mechanism in the world. We often think of gears and teeth in the context of clocks, but this is much, much older.
The oldest gears in the world. But why are they used in this astrolabe? This is the back cover, to which the gears are fixed. Near the top are two small windows indicating the moon phase and the date. The gears are used to change these two settings.
Craftsmen in the Islamic world were much advanced of anything which was happening anywhere else in the West, for example.
Why did the people of medieval Islam find it necessary to make observation instruments as refined as this? A hint can be seen in another astrolabe shown to us by Ackerman. "12 familiar constellations, including Taurus and Gemini, are engraved on the astrolabe." This astrolabe was in fact used for astrology.
Actually, one of the drivers of having very precise astronomy is to be able to do very precise astrology.
In astrology, personal and social phenomena are predicted from the positions and movements of the sun, moon, and stars, as seen from the Earth. An authority on astrology, Charles Burnett of the University of London, explains that astrology was once considered a natural science.
If the sun and the moon were obvious causes of things on the surface of the earth, then surely the other moving planets, that is Mercury, Venus, Mars, Jupiter and Saturn, must have some influence as well. Astrology was an integral part of the belief of how the universe functioned. It was, as I say, part of natural science.
To demonstrate the importance of astrology to medieval Islam, Burnett shows us an illustrated miniature. It depicts a war in the 16th century Ottoman Empire. The fierce battle is painted in vivid detail. Looking closely, we see an astrologer standing amidst the soldiers, holding an astrolabe. What might he be doing?
He's holding his astrolabe up to face the sun in order to make some important judgment concerning the battle.
In medieval Islam, astrology was invaluable for determining not only battle outcomes, but also city construction, imperial marriages, and other important national decisions. Therefore, astronomy was considered necessary for the sake of practicing astrology.
One could not understand astrology without knowing astronomy. One could study astronomy without astrology, but on the other hand, what's the point of doing that? Because whatever you study should have a practical outlet, and the practical outlet of astronomy is astrology.
Astronomical observation technology was developed for the sake of astrology in medieval Islam. An observation device which was the greatest culmination of this technology can be found in Uzbekistan. The city of Samarkand was prosperous as a stopover on the Silk Road. Numerous historic buildings remain from that time. The main buildings have been designated World Heritage Sites and bustle with crowds of tourists. The Islamic astronomical instrument is a ways from the city center, on top of a low hill. This is Shuhurat Egamberdiev, an astronomer at the Uzbekistan Academy of Sciences.
Мы находимся с вами около останков самого крупного инструмента, когда-либо созданного исламской наукой.
Where exactly is the instrument? We pass through the entrance, where visitors are gathered, and see a trench in the ground. This, apparently, is the observation device. There is a steep slope inside. We ask Egamberdiev to guide us. The trench is 10 meters deep and about 20 meters long. Particularly noticeable is a bow-shaped structure made of stone. They used this to make observations.
Это обсерватория Улугбека, это главный инструмент обсерватории Улугбека, который являлся самым точным астрономическим инструментом до появления телескопических инструментов.
The observatory was used to measure the position of the sun. It was built about 600 years ago in order to make an accurate calendar. It is thought that the bow-shaped structure underground continued 30 meters up above ground. A circular building surrounded the structure. There was a small hole at the top of the building. The sunlight would strike the bow-shaped structure inside. This setup formed an important mechanism.
И вот через это отверстие сначала зайчик сюда падал, а потом сюда, и его положение с очень большой точностью фиксировалось с помощью этого инструмента.
The astronomers in the observatory measured the position of the sunlight on the bow-shaped structure each day and took detailed measurements of the slight differences. But why was it necessary to build such a huge observatory? At the time, observations of the sun were normally made with devices a few meters in size. However, precise measurements could not be taken because the degree markings on the devices were so close together. The Ulugh Beg Observatory attempted to take more precise measurements by making the device much larger. When it was built, the observatory was equipped with a tool to accurately measure the angle of the sunlight on the bow structure. A metal ruler. Each degree was around 70 centimeters wide. This made it possible to measure with finer than 0.1 degree accuracy. This gigantic yet refined observatory was built by Ulugh Beg, the ruler of the dynasty reigning over the 15th century Samarkand region. He was also active in astronomy. Ulugh Beg established a school in order to promote astronomy, known as the Ulugh Beg Madrasa. The outer walls are decorated with geometric mosaics that bring to mind the image of space. In its prosperous days, dozens of astronomers would gather here to record and analyze observational data. This is the Ulugh Beg Catalogue of Stars, in which the data from the observatory are recorded. The brightness, position, and other data are gathered for the sun, moon, planets, and over 1,000 stars. The most surprising discovery of all is this. According to our measurements, the length of one solar year is 365 days, 5 hours, 49 minutes, and 15 seconds. This is the length of a year, calculated from the measurements of the Ulugh Beg Observatory. According to modern scientific calculations, a year is 365 days, 5 hours, 48 minutes, and 46 seconds long. Only a 29-second difference. The observatory yielded astonishing accuracy.
Таким образом, обсерватория Улугбека была кульминацией самой высокой точкой периода, который называется исламская астрономия. То есть самой высокой точкой.
Now, a never-ending flow of visitors comes to the remains of the observatory. It is a point of pride for the local people.
Hozirmizda Ulug'bek observatoriyasini ko'rib chiqdinglar.
Endi bunaqa odam umuman bundan keyin bo'lmaydi-da, o'sha paytga bir o'tganda.
Taassurotlar juda ham yaxshi. O'rta asrlarda bunday ajoyib maqbaralar yoki nimalarda observatoriyalar qurilishi ajablanarli hol umuman olganda.
Oilali bo'lganimizdan keyin farzandlarimizni olib kelamiz, oilamiz bilan kelamiz, tez-tez kelib turamiz.
Our next topic takes us to Europe. Torun, a city located in western Poland. Tourists are drawn to its historic streets, left over from medieval times. It is also known as the birthplace of Copernicus, who proposed the heliocentric model of the solar system. Nicholas Copernicus was an astronomer in the 16th century. He revolutionized astronomy by proposing that the Earth revolved around the Sun, rather than the other way around. However, it has recently been found that the ideas and techniques of Islamic astronomers held an important key to this proposal. Was the heliocentric model entirely Copernicus's original idea? We will explore the mystery behind its birth. This is the childhood home of Copernicus, which is now a museum.
Dzień dobry, witam Państwa bardzo serdecznie w domu Mikołaja Kopernika. Zapraszam do środka.
Inside, the way Copernicus lived has been faithfully reproduced. And the observational devices he used are on display.
Tu widzimy jeden z instrumentów, którymi posługiwał się Mikołaj Kopernik. Jest to astrolabium płaskie.
The astrolabe, developed in the medieval Islamic world, spread to Europe around the 11th century. Copernicus used an astrolabe and other instruments to make many measurements of celestial bodies. It is said that he then began to question the Earth-centric model that was assumed at the time. Observations using instruments of Islamic origin thus contributed to the birth of the heliocentric model. It has been recently discovered that Islamic astronomy also played a large role in the fundamentals of heliocentrism. Robert Morrison of Bowdoin College in the United States made an important discovery when verifying Copernicus's theory.
While traditionally Copernicus has been seen as an isolated genius, we found that he relied heavily on Islamic astronomy.
Morrison and his colleagues noticed one particular diagram drawn in Copernicus's book. It was a geometric model, largely used to explain the motion of the planets. This model made it possible to explain the strange motions of the planets as seen from Earth. However, it has been discovered in recent years that Copernicus was not the first person to think of this model. This is the Vatican Apostolic Library, which contains rare documents from all ages and places. In this collection is a book that links Copernicus and Islamic astronomy. It is a document on astronomy that was written in 13th century Persia.
È la presentazione del modello cosmologico di Attusi sulla meccanica celeste.
In the book is the following diagram. It closely resembles the one in Copernicus's book. It is, in fact, the same geometric model as the one Copernicus used. A 13th century Persian astronomer known as Tusi was the first person in the world to conceive of this geometric model.
Questo diagramma ci presenta la coppia deferente epicicloide, nota appunto come coppia di Attusi nella versione formulata da Attusi. Stiamo parlando dell'ultimo grande astronomo, lui persiano ma di lingua araba ovviamente, del periodo abbaside. Muore nel 1274.
Tusi passed away some 200 years before Copernicus was born. Did Copernicus refer to the ideas of the Islamic astronomers? Or was the similarity a coincidence? An influential clue has recently been found that may help solve this mystery. Morrison discovered this document at the University of Cambridge.
Unfortunately, it doesn't start till about page 40.
It is the autobiography of Moses Galeano, a Jewish astronomer who lived in 16th century Turkey. The book records an astronomical theory conceived of by Islamic astronomer Ibn Shatir. Ashatir is known as the astronomer who improved upon Tusi's geometric model, the Tusi couple.
Ibn Shatir was one of the most technically sophisticated and advanced astronomers of Islamic civilization. And Ibn Shatir's theories have been shown to be foundational for some of Copernicus's early theories.
Morrison also noted a record that Galeano stayed in Venice, Italy around the year 1500. At the same time, Copernicus was studying at the University of Padova in the outskirts of Venice. The first university in Europe to admit Jewish students, the University of Padova flourished in the exchange of knowledge. According to Morrison, the Jewish astronomer Galeano was the key person who connected Copernicus with Islamic astronomy.
Galeano is the most likely intermediary for Islamic astronomy to Copernicus. I would say that if Copernicus had not gained knowledge of Islamic astronomy, I don't see how he could have produced the astronomy he did.
Heliocentrism is said to be one of the greatest revolutions in scientific history. Behind its conception lie the achievements of Islamic astronomy. In medieval times, Islam led the world in its study of astronomy. However, from the 16th century on, it began to lose power with the decline of the Islamic dynasty. It would be a long time until Islamic astronomy would take center stage again. Today, in the 21st century, the Islamic world is attempting once more to be pioneers at the forefront of astronomy. At the vanguard of this effort is the United Arab Emirates. Since 2006, they have been working on space development, such as the production of new satellites. They have just begun a plan for a Mars exploration to be launched in 2020. They aim to free themselves from dependence on oil and become a country focused on advanced scientific development. Currently, they are advancing technology and training professionals at a rapid pace in order to achieve this goal. At the nucleus of this plan are the young engineers. The revival of Islamic astronomy lies in their hands.
And it is time now for us to go back to astronomy and to come, all of us as humans, to bring the humanity into the future challenges.
In medieval times, when European astronomy was at a standstill, Islamic astronomy was the most advanced in the world. By developing observation techniques and gathering data, they unraveled many mysteries of the universe. Those achievements would lay the foundation for modern science, most notably the heliocentric model. Without the accomplishments of Islamic astronomers, science as we know it today may not have existed.